All right, Math 206 students, we're finishing up the geometry in 3D unit. All we have to do now is recognize what the regular polyhedra are. These are sometimes called the platonic. And if you're thinking of the corresponding solids where everything is filled in, these are called the platonic solids. The reason they're called the platonic solids is because Plato was actually interested in these shapes. He thought that they represented the 5 elements. So a convex polyhedron is a polyhedron where each segment connecting any 2 points in the interior of the polyhedron is actually in the interior of the polyhedron. So that just means it doesn't have any divots or dents, anything that caves in. So these would all be examples of convex polyhedron. And a regular polyhedron is a convex polyhedron where the faces are all congruent, regular polygonal regions, such that the number of edges that meet at each vertex is the same for all vertices of the polyhedron. So let's just look at this one, for example, this octahedron. Each face is a regular triangle. And remember, regular triangles are called equilateral triangles. So each face is an equilateral triangle. And also the number of edges that meet at each vertex is the same. So look at each vertex here. You've got 1, 2, 3, 4 edges coming out of it. And that would be the same for every other vertex. Look at this one in the back. It's got 1, 2, 3, 4 edges coming out of it. And this one down here, it's got 1, 2, 3, 4 edges coming out of it. So each vertex has 4 edges meeting there. All right, so that's true for this is a tetrahedron, equilateral triangle, and there are 3 edges that meet at each vertex. Here you've got a cube made up of a whole bunch of squares, which are basically like equilateral quadrilaterals. And you've got 3 squares meeting at each, or 3 edges meeting at each vertex. Here you have a dodecahedron, which has 12 faces. Each face is a regular pentagon, and there are 3 edges meeting at each vertex. And then the icosahedron, which has 20 faces. Each face is an equilateral triangle, and there are 5 edges meeting at each vertex. It turns out these 5 shapes are the only regular polyhedron that exists. These are the only 5 that could possibly be. And we'll do an example during office hours where we go through why that's the case. All right. And lastly, I want to discuss what nets are. Nets are patterns that can be used to construct the 5 regular polyhedra, or actually they can be used to construct any 3-dimensional shape. So if you imagine taking this, cutting this out and folding it up, you would get the 1, 2, 3, 4, 5, 6-sided square cube. So this would give you the cube. This is the net for a tetrahedron. This is a net for 1, 2, 3, 4, 5, 6, 7, 8. It's got 8 faces. If you fold it up, what you get is the octahedron. Here is the net for the dodecahedron. And here's the net for the icosahedron. And I will post for all of you the nets for each one of these shapes. And I do want you to print them out, cut around the edges, and fold them up, tape them up, just so you get some experience working with nets. A handful of your questions on your homework have to do with nets of objects.